All right, here we go. Let's do the next. It's the same section, but it's a different part of it. So yesterday we did the difference of two squares. So we're going to do the difference of two cubes, but not just that, but the sum of two cubes. Remember yesterday there was no sum of two squares. All right, so there is no factoring of the sum of two squares. You had a problem. Remember I said the answer, you couldn't factor it? What was the question? Wasn't it like x squared plus 25 or something like that? Yeah. That cannot factor. Okay, there are no two things that multiply together to become this. Everybody see that? All right, so you can't factor it. Now, if you had this, if you had x squared minus 25, yes, you can factor that. All right, so there are two things that multiply together to become x squared minus 25. This is a difference of two squares. So what you would do, this is just a brief review, what we did yesterday. Actually, let's do this. I always like to put a plus or minus there first. We're going to do something very similar to that today with the two cube things. And it's super, super important, all right, that you understand that. Put those signs right there. You put an x here, x here. What's being squared to give you 25? Put a 5 here, boom, you're done, that's it. But you cannot factor x squared plus 25. Okay, there is no sum of two squares, there's only a difference. But when you have cubes, guess what? You do have a sum of two cubes, and you kind of do them the same, all right? They're very, very similar. The only thing that's different is a couple of signs. That's it. You just switch two signs, and you can do the sum and difference of two cubes. So let's very quickly just go through. We did this with squares. We're going to do this today with cubes. So let's find all the perfect cubes, all right? So let's start at 1. Okay, what's 1 cubed? It's 1. 1 times 1 times 1. That's 1. Everybody with me? All right, I'm going to go up to 10. All right, I'll do kind of quick. So what's the next number? Not 1, but what? 2. So we're going to go 2 what? Cubed. Can you do that in your head? A couple of these, the first couple you should be able to do in your head. After that, you might have to think about it, maybe use a calculator after a few of them. All right, but what's 2 cubed? You should be able to do that in your head. 2 times 2 times 2? 8. It's 8. Very good. So 2 cubed is 8. What I'm trying to get you to do is recognize some of these numbers. That's a perfect cube. That's a perfect cube. We want to be able to look at those numbers and say, oh, okay, that's a cube. We're probably going to do that difference of two cube things, or that sum of two cube thing. All right, so I'm just doing this so you can recognize the cubes. What, I got like 3 people looking at me? 4 people maybe? All right. I'm just going to teach. I don't care if nobody's watching. I'll just keep teaching. So anyway, 3 cubed. This is another one you should be able to do in your head. 3 times 3 times 3. What's that? 3 times 3 is 9. What is the whole thing? 27. That's right. It's 27. Just put it down there. All right. All right. So that's another cube. Let's do a few more. Let's do 4 cubed. I don't know if you can do that one in your head or not. It's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is, anybody? 64. You probably can do 5. The rest of them you probably can't do in your head, and I probably couldn't do in my head. All right. But I have them written down, so I'll put them down. 5 cubed I can do, and you should be able to do. It's 5 times 5 times 5. 5 times 5 is what? 25. 25 times 5. Everybody should be able to do that in here. It's 125. What are you thinking of when you multiply by 25s? Quarters, exactly right. Okay, so if I had 5 times 5 times 5, that's 25 times 5. That means I got 5 quarters. That's $1.25 or 125 cents. All right, so let's do some more. Let's go 6 cubed. I'm just going to write them down. You know how we get them. It's 6 cubed, 6 times 6 times 6, which is 216. These I don't really have memorized, I'll be honest with you. 7 cubed is 343. I'm just looking off my paper that I put my notes on. 8 cubed is 512. Again, how do we find these? 8 times 8 times 8, right? 8 times 8 is 64. 64 times 8, I can't really do that quickly in my head. Maybe if it gave it some time, I might be able to do it, but probably not. All right, so 9 cubed is 729, and 10 cubed, everybody should be able to do 10 cubed. What's 10 cubed? It's 1,000, that's right. Okay, so those are numbers, probably not these really big numbers. They probably won't give you these. Okay. All right, so those numbers you should recognize. I would probably say, I think I've seen problems where they gave you 216, so that's one that you should kind of know. 125 definitely, 64, 27, 8 definitely are ones you should look at and you should recognize. Let's do one more thing with some variables in here and see if they're perfect cubes or not, and that's helpful as well. So what if I did this? What if I said x to the 9th, y to the 6th, z cubed? Is that a perfect square? Everything that I circled here are not squared. I'm going to yesterday. What am I trying to do? Perfect cubes, that's right. Is this whole thing a perfect cubed? It is, because I can cube something to get x to the 9th. I can cube something to get y to the 6th, and I can cube something to get z to the 3rd. So how do you know if you can cube something to get to this? What do you do with these exponents? We talked about this yesterday with squares. So anytime you have an even exponent, right, that means you squared something to get to that. That's right. If you could divide by 3, if you could divide these exponents by 3, then they're perfect cubes. Everybody got that? So can I divide all three of these numbers by 3? Sure. All right. What do we get when I divide that by 3? This would be x to the what? X cubed, x to the 3rd, and then this would be y squared, and this would be z. So that means that this thing right here, cubed, is this. So that's a perfect cube. All right? Again, it's good to recognize it, because what we're going to do here in a few minutes is we're going to look at some numbers and you're like, oh yeah, that's right. That's a cube. We can cube that. We can cube something to get to that. Everybody with me? Yeah? All three of you? Good. So I appreciate the ones that are paying attention and listening. I'll say that. All right, here we go. I've got a couple formulas to learn. It's really basically one formula to learn, but the other one you just switch a plus and a minus around. That's it. So if you can memorize the one, the other one should be just as easy. All right, so I'm going to write down two formulas. One is for the sum of two cubes, and the other is for the, what do you think? The difference of two cubes. And I have a way, I don't know, it's not like I patented this thing. It's not that exciting. It's not like FOIL method, or it's not like, well, I was going to say SOHCAHTOA. Does anybody know SOHCAHTOA? Nobody knows that? Okay, what does that stand for? SOHCAHTOA. Give me some words. Give me one word. What's the T stand for? It's TOA. Yeah, the SOH goes together. The CAH goes together, and the TOA goes together. What do they stand for? What's the S stand for? It's on your calculator. No, it's not sin. It looks like sin on your calculator, but the word is actually sine. It's actually sine. All right, it's just shortened version. Sine, cosine, tangent. Anybody heard of sine, cosine, tangent? Okay. Apparently you didn't do that in Algebra 2. We're doing that now in my honors geometry class, so I'm teaching them that in geometry. You should, by the time you finish Algebra 2, you should. But, you know, it's water under the bridge, right? We're where we are now. So let's do this. The sum of two cubes. Here's what I do. I write 2. Let's do this first. Before I do that, here's what we start off with. If I have x cubed plus y cubed, I can actually factor that. This is a sum of two cubes. Of course, what would this look like? What would the difference of two cubes look like? X cubed minus y cubed. Very good. All right. So I can actually factor both of these. Now let me show you. Here's a long explanation of how to get to it. I actually watched a video the other day. Comes up on my once I watch one math video, you know how it goes on YouTube, right? Everything gets recommended to you. So I watch all these math videos, and somebody showed, and I've never done that before, ever since I've taught this stuff. I just show you what the equation is. But it was really cool. I don't even know if I can remember how to do it right now, but it was really cool on how we got to this thing that I'm going to show you. So anyway, let's just show you. I'm going to put two parentheses. The one parentheses is going to have two things in it, and then the second parentheses is going to have three things in it. So I'm going to make my second parentheses just a little bit longer because I got to fit three things in that one. Everybody with me? Here's the thing that I came up with. When you're doing the sum, and that's a positive, you're going to have two things in here, so you're going to have a sign in the middle, correct? You're going to have three things here, so how many signs are you going to have? You're going to have two, one here and one here, okay? So the first thing that I do when I factor these things, excuse me, oh, sorry, YouTube. All the three people that watched, meant to cover up the thing. Anyway, here we go. So first thing I'm going to do is put my signs in here. Here's how I remember it. It's not as cool as FOIL, and it's not as cool as SOHCAHTOA, but here's how I do. I go this, same, opposite, positive. Yeah, I don't usually say SOP, but you could say it, SOP. All right, same, opposite, positive. That's how I remember this. What does that mean? It means I put the same sign right here as I have here. So what sign is this going to be? Plus. Okay? And then I'm going to put a sign right here. What's that one going to be? Minus, because it's what? It's opposite. And this one's always going to be what? Plus, positive. Okay? Same, right? That's the same sign. That's the opposite sign. And that's always going to be positive. If you can remember that, that's half your battle. But now you got to know what to put in there. All right? So just watch. I'm just going to show you what goes in there. I'm not going to tell you why it does. Just remember it, because we just don't have time to do all that anyway. So watch what I'm going to do. See how this is x cubed, y cubed? I'm going to put an x right here and a y right there. So far, so good. That's easy, isn't it? Yep. So whatever is being cubed, listen to me very carefully. Whatever is being cubed, that's what you're going to put here. This could be a number. It could be a letter. All right? It could be a variable. It could be several different variables. All right? So whatever is being cubed is going to go right here. If you wanted, you could put like a parentheses around this. In this case, you don't really need it. There are some situations where you do need it. All right? Everybody good so far? Now, what I'm going to do is I'm going to put ones on the end. The first one and the last one. So what we're going to do is take that first one, we're just going to square it. And that should kind of make sense, because if I went and distributed, what's x times x squared? It's x cubed, isn't it? Does that make sense that this should be an x cubed then? Because if I was to distribute it, this times this is going to give me x cubed. And at the end, this is a y. What's this going to be? This is going to be a y, not cubed, squared. Okay? That's the easy part. And the middle is not too hard, but sometimes it's hard to remember. Now what we're going to do is take the x and the y, and we're just going to multiply them together and stick them in the middle. So if I multiply them together, what do I get? xy. And that's your little formula for the difference, or the sum, in this case, the sum of two cubes. So I'm going to put that in a box. Put that whole thing right there. So that's something you're going to have to memorize. What I would do, before you do your homework tonight, I would write this down 4, 5, 6 times. All right? Maybe first couple times you're looking at it and you're just writing it down. Then you put it away, right? Blank slate of paper, blank piece of paper, and then you write them a few times just by memory. All right? That'll be a good help for you. All right? Same, opposite, positive. xy here, x squared, y squared here. And in the middle, you multiply those two together. It's that easy. Okay? Let's do this one. This works exactly the same way, except the same, opposite, positive has a couple differences. The same and the opposite. All right? So let's do that first. This is a difference of two cubes. This time we have a minus in between here. So remember, it's same, opposite, and this one's always positive. So what's the sign going to be right here? It's going to be minus. What's this sign going to be right here? It's going to be plus. What's this one always going to be? It's always going to be plus. Okay, so that one's always going to be plus every time. It's these two that could change, right? So if it's a sum, the first one's positive. If it's a difference, the first one's negative. It's kind of easy to remember, isn't it? So far? Yeah. So without looking, all right, what goes here and here? X and y. Easy. All right, what goes on the ends of this one? X squared and y squared. And then what goes in the middle? You just multiply these two things right here, so that's xy. So if you can remember those, you should be able to do most of these difference of two cube problems. And they shouldn't be all that difficult. It looks complicated, but it's really kind of easy. Kind of. All right? I'll drop that down again so you can see them both. See, they look exactly the same, don't they? Except for two of the signs. That's it. So really, you only have to memorize one thing. And if you can memorize same, opposite, positive, you should be able to do this whole thing right here. It's pretty straightforward. All you're doing is just taking numbers and you're just throwing it into a little formula that we have. Ready to do an example now? Yeah, let's do a few. I've got a bunch of them to do. Again, this is continuation of 5-5, so it's not example 1. It's going to be example 6. But this is the first example for the sum and difference of two cubes. All right, and here's what they say to do. They say to factor, and they don't tell you. They won't tell you on the quiz. They won't tell you on the test. They don't tell you on the homework to use difference of two cubes or use the difference of two squares, okay, or sum of two cubes. They don't tell you. They just say factor it. So you have to recognize it. You got to be able to look at it and say, which method am I going to do? Am I going to factor out a greatest common factor? Is this a difference of two squares? Is this a difference of two cubes? Is it a sum of two cubes? You got to look at it and decide what kind of factoring are we going to do here. All right? So that's what you want to do. So here it says, it's a cubed plus 8. I'm going to do one thing to arrange it just a little bit differently, and then we can factor it. All right. First of all, is this, it's a sum, isn't it? So is this a sum of two cubes? Is something being cubed right here? Yes. What's being cubed? A. What's being cubed right here? A 2. Right, that's 2 cubed. That's why we did all those numbers at the beginning, so you recognize that. So here's what I'm going to do. I'm going to write it, a cubed, didn't really need to change that, and I'm going to write this what? 2 cubed. So that I see my cubes right there. This is kind of the x, right? So if you jump down to there, okay, there's the x, there's the cube, there's the y, there's the cube. So a is kind of like my x, 2 is like my y. Good so far? It's been pretty easy to understand so far, right? Yeah, I think so. All right, let's do it. So what do? I put my two sets of parentheses. I know 2 things are going to go in the first one, 3 things in the second one, so I make the second one just a little bit bigger. Now, I don't put some numbers in yet. What do I put in first? The plus or minuses, okay? So we look at this. This is a positive. So it's same, opposite, positive. So what goes here? Plus. What goes here? Minus. What goes here? Plus. That's how I start it, okay? Always start it that way. Now, what goes here and here? It was x and y, but now, what is it? It's a and 2. Very good. So it's a and 2. Okay, we're just following that formula. I don't have it in front of you. You have it in your notes probably right there. All right. Now, what goes here and here? It's a square. Very good. Because we take this one and we square it. And we take this one and we square it. Let's do that in our head. What's that? It's 4, right? Okay, yeah, 2 squared. 2 squared is 4. I don't need to put 2 squared there because I can do that in my head. So I put a 4. Yes? One more thing and we're done. Okay, that's right. What do I do with these two? Multiply them together and stick them in the middle. I don't go A2. A2 looks weird, so I put what? 2A. Now, you do have to do this, though. You got to look at it and say, can I factor this any further? Can I factor this any further? Nope, I can't. All right, so I'm done. That's it. That was pretty easy, wasn't it? If I wrote what? No. Yeah, but don't do it. I wouldn't mark it wrong. If you put a 2 squared there, I wouldn't mark it wrong. Some teachers might, because they say to simplify everything, but put a 4. Okay? Everybody good? All right, let's do another one. Ready for another one? Yeah, that wasn't too hard. That was super easy. So, example 7. It says factor. I'll write it every time, I guess. Factor. All right, here we go. It's 27a cubed minus 64b cubed. Now remember, thing we did at the very beginning, right, with all the perfect cubes. Okay, so look at it It's a minus. So when I see two things in a minus, first thing I think of is the difference of two squares. Is this a difference of two squares? No, nothing's being squared here. Well, there is something being squared, right? 64. 8 times 8 is 64, that's true. But nothing's being squared to give you 27. Nothing's being squared to give you a cubed. But they are being cubed. So what is being cubed here? What cubed is 27? 3. That's right. 3 is being cubed, correct? What's being cubed to give you a cubed? The a. So watch what I'm doing. I said this earlier. Remember I said you didn't have to put those other ones in parentheses, but later on you will for some of them. This is that situation. All right. So this is 3a cubed. So what's being cubed? 3a. Minus. What's being cubed to give you 64? 4 is. 4 cubed is 64. So I put a 4 here. What's being cubed to give you b cubed? Just a b. Put it in parentheses. Put the cubed on the outside. Now we have it set up perfectly to do our difference of two cubes. All right, there's our difference. This is being cubed. This is being cubed. So now it's just a matter of just chucking it in. All right, so let's do that. First thing, my parentheses. All right, and same, opposite, positive. So same, negative, opposite, plus. This is always positive, so we put a plus. All right, this is x and y, but what's being cubed right here? The 3a. So I put a 3a right here. Whoops, what's that thing? There we go. And what goes here? Just 4b, because that's the thing that's being cubed. It's kind of like our y, isn't it? This is kind of like our x. This is kind of like our y. So what's being cubed? 4b. So I put a 4b right here. All right, so you're on the right track. What do we do to this one? Square the first one, don't we? So we take this and we square it. What do you get when you square that? It's 9a squared. You got to square the 3 and the a. So it's getting a little bit more difficult. Not much, just slightly. What goes here on the end? That's the next one I do. I take the second one and I square that. So 4 squared is 16 and b squared is b squared. All right? All right, so I'm looking here, I'm just squaring that. I'm looking here, I'm squaring that. Boom, right there. Now, what do I do to the middle ones? What do I do to those two? Just multiply those two together. So let's do it. 3 times 4. And don't worry about the sign. Don't worry about that being a negative. We already figured out what our sign's going to be, okay? So 3 times 4 is 12. And then what? AB. All right? And that's it. Always look to see if you can factor more, though, because I don't know if it's the next one or not, but you will be able to factor a little bit more on some problems. But can you factor this? Does that even look recognizable? No. So we just leave our answer like that. So this times this is 27a cubed minus 64b cubed. If you wanted to, if I had more time, if we had more time left in the year, I probably would take the time and show you that this is actually equal to that. If you wanted to on your own, if you felt curious about it, how could you do it? Just take 3a, multiply it by all of those, take minus 4b, multiply it by all of those. Stuff will cancel out, and you're going to be left with that. If you wanted to do that on your own. Just not going to take the time to do that. Okay? All right. Let's do another one. Example 8. We're rolling right along. This one looks even a little bit weird. You know how it goes, right? They start off super easy, and they generally get a little tougher as you go on. Same thing here. It says to factor. And what do we have? A cubed minus c plus d cubed. All right? So this looks a little weirder because you got a plus in between here. So what's our x in this situation? Remember we started with that equation. We said x and y. What's our x here? It's the a. Okay, what's the y? C plus d, right. So wherever you see an x, you're going to put an a. Wherever you see the y, you're going to put a c plus d. All right? I'm going to write it here. I'm going to give myself some room. Let's put the signs in there. This is minus. It's a difference. So same, opposite, positive. And then we just take what's being cubed, and we put it here. What's being cubed on the first one? A. What's being cubed on the next one? C plus D. Now, you got to be careful. Here's the first roadblock. What do you think you have to do? You got to put it in parentheses because you're subtracting this sum right here. It's very important. You don't just put A minus C plus D. You're subtracting what? C plus D. So we're going to have another step to this problem. One of the steps is going to be to distribute that negative through. Everybody see that? All right, so make sure you always look for stuff like that, especially when you have pluses and you got a minus, on the outside, or even if you had a negative inside of here, all right, a negative on the outside. You're going to have to distribute that through there. We'll do that in a minute, all right? What goes here? Well, we take the first thing and we square it, correct? That's easy. What is it? It's a squared, yeah. Now, here's the next one. I'm not going to actually do the math right now. I'm just going to write it. What? What's being squared? C plus D. And I put it in parentheses. It's very important that you do that. Everybody good so far? That's my X, that's my Y. Yeah, not that big of a deal. What do we do here? I take these and I multiply them together. That's right. So I'm going to put an A. And don't worry about this sign right here. Okay, we've already got our sign. We know it's going to be a plus. So A times what? C plus D. And I need to put that C plus D in parentheses. It's super important that you put that in parentheses. Yes? All right, let's figure this out. When are we out of here? Quarter of?
2 minutes.
Yep, quarter of. All right, here we go. Let's now distribute this negative. So what am I going to get? A, what? Minus C, what? Minus D. And then A squared, A squared plus, let's distribute this A through this. So it's AC plus AD. Plus, how do we multiply that together? Let's do it off to the side, okay? This is off to the side. What's C plus D? That quantity squared. It's C plus D times C plus D, correct? We have to do FOIL method. I'm going fast because the bell's going to ring any second. So C squared plus what? CD plus another CD. Outside, inside is FOIL method plus D squared. Add up these two. It's C squared plus 2CD plus D squared. That's going to go right here. It's kind of weird, but that's what it is. 2CD plus D squared. All right, look to see if I can simplify this. Are there any like terms here? No, there's no A squares, no D squares. Nope, there's no like terms, so guess what? That is my answer. Now, we didn't quite finish, but you could probably do, I don't know, my guess is about half of them. A lot of you guys are leaving and not listening to me. So you're going to do about 45 to 63. That's supposed to be a 63 odds. Everybody's leaving. Oh my gosh. Can't believe everybody's leaving. You probably won't be able to get all the way to 63, but you should be able to do most of them, I would guess. Okay, I would say the majority of these you should do. So don't just do half. Do as many as you possibly can. Okay, I don't know. It's section 6. It's 5.5. Just look at 5.5. I'd have to open up my lesson plan. It's 5.5. Just go to 5.5. It's the same. I think it's 3.15. It was the same page as what you did on the other homework. Okay, I think if I remember right. Yeah, it's 3.15. Page 3.15. All right, that's enough of that.